These are in listen-only mode.
Good afternoon, everyone. This is Mark Albert, Editor-in-Chief of Modern Machine Shop Magazine. Welcome to our webinar sponsored by FANUC FA America. Thank you for joining us. Our topic this afternoon is CNC Programming Made Easy with Manual Guide I Conversational Program. Part 1, Overview and Setup. Without particular knowledge of G-code programming, it is possible to generate part programs on the shop floor by answering simple questions. FANUC's Manual Guide I Conversational Programming provides this capability for milling, turning, and mill turn centers with FANUC CNCs. This webinar will give an overview of the functionality of Manual Guide I and will also highlight several steps to setting up the software efficiently, setting up your tool library, and setting up both your turning and milling fixed forms. By the end of this webinar, you will know all the preliminary work you need to do prior to starting to create a new program. Our presenter today is Jody Michaels. As End User Account Manager for FANUC FA America, Jody Michaels' focus is on servicing and supporting end users to maximize their productivity with the use of FANUC CNCs. Jody has 35 years' experience in the machine tool industry with various positions in sales, support, automotive applications, and training at machine tool builders, end users, and CNC suppliers. He is a true expert on CNC programming and the functionality, setup, and use of Manual Guide I. As we listen to Jody during the presentation, please feel free to share your questions with us by typing them in the questions pane on your control panel. They will answer these questions at the end of the presentation. This webinar is being recorded, so you'll be able to view the entire program online later. Thanks again for taking time to be with us for the live program. Here's Jody.
Thank you, Mark. Good afternoon, everyone. As Mark said, today we're doing a Manual Guide I, Part 1, Overview and Setup. I just want to let you know that it is Part 1, and as Mark said, it is about the overview and the setup. We'll do an overview of all the cycles, and then a setup of our tool data, and then also all of our fix forms. And then next month we'll do one on a lathe program, and then in March we'll do a milling program. So it will be a 3-part setup for this. Today's just the overview and the setup. And one of the first things we need to talk about is what exactly is Manual Guide I? Well, what Manual Guide I is, it's a powerful onboard conversational programming system that is available that uses intuitive machining cycles, both turning and milling. That you use one screen to fully program a part. You can check the part using simulation, set up your tooling, your workpiece offsets, and then actually machine the part from within that system. And it's used on a wide variety of lathes, both vertical, horizontal, inverted, twin spindles, and then also machining centers, both vertical, horizontal, and all different types of machines that are built by a variety of manufacturers from all over the world. What Manual Guide I does, it generates a G-code format program that you can store for later use. Also, from within the system, you can import offline G-code programs into the system and run those and also simulate those within Manual Guide I. Also, FANUC does have something called NC Guide, which is FANUC CNC software running on a PC like your desktop or a laptop, which includes support for Manual Guide I. And it's a great tool not only for actually doing the program, but also for training your operators or your programmers or whatever to actually use the machine. Now, some of the benefits of Manual Guide I. There's 5 of them that I try to extol all the time about Manual Guide I. And these aren't in any particular order of importance or anything like that. But the number one thing is ease of use. And the reason I say that, as we go through this overview of all the cycles within Manual Guide I, you're going to see that all of these different cycles are very similar. They're very similar. As you set one up, you have your cutting conditions, your detail data, and then any geometry associated with each cycle. But as you can see, once we go through those, they're very similar. That's very important for your operators. Once they get acclimated to one way that it's set up, the next one will be very easy. Number 2, flexibility. And the reason I say that is all of us that are listening in today, or most of us, we're all programmers or operators or whatever. And we've all got a certain way that we do things. Like when we do a tool change or when we go to a clearance position, we've all got a certain idea of how we want to do that. With Manual Guide I, you can set it up the way you want to do it. Not the way I want to do it or the way your boss wants to do it. The way you want to program it, you can set it up that way. So it's very flexible. Also, Manual Guide I, it's a learning tool. As you make programs and produce all these G codes, when you're in the edit mode and you scroll down through a particular program and put the cursor over a certain spot, it will give you an explanation of what that G code is or what that M code is. So that's very good for your operators or your programmers that might not necessarily know what all these G codes are. It'll give them an explanation of that. Number 4, you can put G code and conversational into one program. You don't have to have separate programs for the conversational or for the G code. You can mix and match it. You can make a program offline on a CAM system, import it into Manual Guide I, and then you could add a conversational cycle within that. That's a very, very powerful part of this tool. And also simulation. You've got the capability of simulating both the conversational programs and a G code program. As long as you have your tool data set up that matches with your CAM system software, you can simulate the program right within Manual Guide I. Now, some of the secrets for success for Manual Guide I. These are critical that you get these set up ahead of time before you actually try to do your programs, because it's going to save you a lot of heartache later. You'll get alarms that you don't understand what they mean. But if you go through these 2 steps prior to starting, and what we're concentrating on today is lathe programming. We'll go into mill later, but today is a lathe program. So that's what we're talking about today. The tool offset and the tool data pages associated with the lathe package. It's important that you set those up correctly. The tool types and all the information that goes with each particular tool. Then number 2, you set up a set of fix forms that fit your needs, as we discussed before, where the flexibility, where you set this up, where the fix forms are what you want. The way you want to start a program, the way you go to do a tool change, the way you start to spindle, make them set up to fit your needs. Now, to actually start Manual Guide I, all builders sort of do this differently. There's a vast array of selections, what button we push to start Manual Guide I. On most of the machines I've done training on, most of them either use the graph function key or the custom function key to actually access Manual Guide I. And what we're showing here is an MDI panel from a mill, and then the next one is an MDI panel from a zero-eye TV control for a lathe, and it's got arrows pointing to the spot. You push the custom button here or the graph button, and that gives you access to Manual Guide I. Once you press those buttons, it takes you to this screen. It's called the all-in-one screen. On the all-in-one screen, it'll be in color, and you have a variety of information on that screen. You still got your position screen. It'll show your machine position, your absolute position, or your relative position. It'll show the active program. It'll show the active tool, the active feed rate, the active spindle speed, if there is a spindle command associated with it, load meters, and then all your various soft keys down on the bottom. Our next screen is just a little bit better screen, and it shows it a little better, where it shows all of our different soft keys. These are soft keys at the bottom of the control. Here's our actual position, our distance to go, our spindle speed. And then once you get into your all-in-one screen, you can then navigate the menus within Manual Guide I. And you can go to a variety of different modes. You can go to Auto, Edit, MDI, and Jog modes, plus your MPG, then page in between the screens using the two arrow keys, the left arrow and the right arrow, which I call the left and right shift keys. And that's just what I call them, just so for your information as we go through the rest of this today. That's what I mean by right and left shift, or the two arrow keys. Now at this point, what we're going to do, I'm going to change screens, go into NC Guide, which is our offline software where we can simulate a total control. I'm going to change screen and go to NC Guide. And the NC Guide I'm showing here, as you can see, this is a FANUC Series 0i Model D control. This is set up for a lathe. And what we're going to do now, and we're in the edit mode, as you can see up here, and what we're going to do is go right shift, because what we want to look at, we're going to do an overview of the cycles for turning, and you can see it shows a little turning tool with a turning type part. And we've got three selections here. We got start, cycle, and end. And we're going to go look and see what's in start. If you press that soft key, it takes you into this. You have two tabs. The start lines, and this will be the fixed forms that are in your tab 1. Then also, if we arrow over, we have blank definition. This is important because typically at the start of the program, you'll do a blank definition. And this is basically for the simulation. For when it does the simulation, it'll show a part that's representative of the piece of stock that you're machining. But again, this is very simple stuff. Just fill in the blanks. If you select the blank, again, it asks for a diameter, a length, and a work origin in Z. Very simple. Very simple. And then cancel out of that. And now what we're going to do, we're going to go into a brief overview of the different cycles on the turning mode. We go into cycle, and we've got 5 different selections here on the software the way I've got it set up. You've got whole machining, you've got turning, you got residual machining, turn grooving, and threading. Those are your 5 different selections for turning. And I'm just going to pick one just as our first example, because again, this is just an overview of the different cycles. If we select drilling, it takes you into a drilling cycle. And see, and it shows a picture of what it's doing. And it also will show, it has the Q highlighted. The first thing it asks for is a pecking cut depth. And we're on cutting conditions for drilling. And you can see next to this, it has an asterisk. Anytime a cycle has a field with an asterisk next to it, you don't have to answer that information. It's optional. But in the example I have here, I did answer that part of it. So what it's asking for is pecking cut depth, and you can see it has Q highlighted. So that's like if you're doing a G83 drill cycle where you want the drill to fully retract, that's what it's asking, the amount of each peck. Then the go past amount, that's just to allow for the angle on the drill. The clearance, that's like an R plane at the start of a drill cycle. Your feed rate, dwell time, again, that has an asterisk. You do not have to answer that information, but that's like dwell time at the bottom of the hole. If you wanted it to dwell for a part of a second, you could put that in. And then the approach motion, anytime the software will give you answers to any of these fields, there'll be soft keys down here at the bottom. So you have 3 different selections. You got a vector move an X and then Z, or then Z and then X. So you got 3 different selections. And then to go to the next tab, we just use our arrow key. Then it asks for the base position in Z. That's just asking what the front of the part is. Then the next one is your cut depth. And as you can see from the screen, you have a minus or a plus. It needs to have either a minus or a plus there. And the reason it does that is this software is used on a variety of machines. So this could be a machine where you'd have a left and a right spindle. So when you would drill on the left spindle, you put minus. If you drill on the right spindle, you put plus. So that's very simple. Then it also has detail data. And again, all four of these have asterisks next to them. So you do not always have to answer that information. But what this detail is say you had a very large drill and you wanted to start it out at a much slower feed rate than what you would actually want it once it got fully engaged. That's what this is for. So where you can start out at a slower feed rate and then increasingly make it faster. So that's what a drill cycle looks like. And then to get out of that, we just press cancel. It takes us back to our turning cycles. And then we can just page over and look at a turning cycle. And you've got a lot of different selections. You got roughing, semi-finishing, finishing, and then rough and finish. So you have 12 different selections here. But we're just going to pick one. We'll select outer rough. And again, it's just fill in the blanks, just like the drilling cycle. Whenever you put information into it, like here, we'll just go Z, Z minus, and then it's asking for a cut depth. And you can see it highlights Q, so that it's the depth of cut per side. This is a radial amount. It's very important that you remember that. It's a radial amount. And once you type in a value there, 0.1, and then you press input right here, it's important that you remember that, because if you try to press insert here or insert there before you put all the information in, you'll get this alarm, short input data. Whenever you see that alarm, that means that you've tried to input the cycle before you put all the information in. That's what that's for. Then the next field is just x-axis finish amount. That's how much finish stock per side that you're going to leave in the x-axis. And then D is just the finish amount you'd leave on shoulders or on the end of the part. Then feed rate, your straight feed rate. Then the angled feed rate, if you're doing a relief, you can slow that down. And then when it comes out of a relief. Then you have detail data. The first one is first feed rate override. That's for like on a lathe, if you had something chucked up in hard jaws where it was running out, you'd have the capability of slowing down that first pass, only the first pass. Then after that, it'll go back to your commanded feed rate. The cut rise method, that's for when you're turning over to a shoulder, when it feeds up to go back to the next move, you always want to use cut there, because otherwise it's going to leave big steps on a shoulder. And the rest are all just clearance moves, and then your approach motion like before. And then also within turning, this is a very nice feature. If you're running chucker work, where you have clearance at the end of the part, you can tell it to face the end of the part. You do not have to make a separate facing cycle. You can do it all within the turning rough. But as a note of caution here, you have to make sure that you're not using a center in the end of the part, because it's going to face all the way down to X0. So you have to have clearance to where you can get to the end of the part all the way down to the center. So that's all the different fields within a rough turning cycle. As I said, what's good about all these, they're very similar. This looks just like the drill cycle. Just fill in the blanks. Then we cancel out of that. We go back into our turning cycles. The next tab is residual machining. And just to give you an explanation of what that is, say for instance we're turning a part that has a large relief that only one particular type of tool will fit into a relief. What the software does, as long as you have your tools described right, it'll look and see if a tool has clearance to get into that relief. If it doesn't, it'll give you a little message saying residual stock will remain. that tells you that you have to go into this cycle and select that and fill in the blanks just like before. Again, it's got Z minus Z plus, and it looks just like a rough turning cycle, exactly the same field. And the software will actually then go take that tool in, the one that will actually fit into that profile, and go in and just take out the stock that's left. So that's residual machining. Again, as I said, it looks exactly like the other cycles. Just fill in the blanks. All right, our next one is turn grooving. Again, we'll select that, and it takes into our grooving cycle. Again, we have two tabs. We have cut conditions, and we have detail. And again, it's just fill in the blank. It has two different types, either center cutting, and that's what you're typically going to use for a groove cycle. What it does, it cuts the center of the groove out, then goes to each side and finishes it based on whatever width you tell it. If you want to use layering, what that does, it only takes layers out. It'll go down so far, rough it completely out, go down a little further, and rough it completely out. That's how that works. But if we use center cutting, then you can leave, again, you can see both of these next two fields have asterisks where you don't have to answer that information. You can, but you can leave a certain amount of finished stock. A feed rate, a pecking, you can tell it to peck, where it just goes in so far, backs out, for where it will break a chip. This is very handy for grooving because we've all been down that road where we do a grooving cycle and we end up with a chip that's about 3 miles long. We don't want that. This is very powerful. It gives you a choice of where you can get around that. You can tell it how deep to go, and then you can have it getting progressively shallower as the deeper the groove gets. This is just a return amount, and then the detail of a clearance like an R-plane, a dwell, and then just the approach motion, and then how far it backs off when it's in the actual groove cycle. And then once you define all that, then you have to go do a figure of a groove. And you select that, and again, it's just fill in the blank. And what's good about it is, like here, it's asking you where you're defining the geometry of your groove, either Z minus or Z plus. So it just depends on how your print is toleranced, whether it's giving a dimension to the front of it. So it makes it very powerful. You know, a lot of them, they always go to the back of the groove. With this, you can go either way. Then another good thing about the grooving, you've got the capability of, on all 4 corners, bottoms also, where you can either define a chamfer or an arc, or nothing. You can make it be sharp corner. And then obviously you can do multiple grooves. You can, however many you want, the pitch, and then which direction they go, whether Z minus or Z plus, based on the geometry of your print. So that's the grooving cycles. And we go back, then we go, we've done our grooving, now threading. Again, threading is very simple. Fill in the blanks again. We select threading, outer. The cutting method, that's just how it is feeding the tool into the thread itself. And it defaults to single A, single amount. And what that is, that's like on an engine lathe when you've got your compound set up on 30 degrees. And as you go in deeper into the thread, it's only cutting on the leading edge of the insert. That's what it defaults to. But you've got six different ways of feeding into it. The finish amount, you can leave a particular amount of finish stock or a particular number of finishing passes. And then also you can have cut type. You can have number of passes or depth of cut. Those are your 2 choices. I'm an old engine lathe guy, so I'm used to cut number. I've got in my head how many passes I want to take, so I always use that. But some people always think in depth of cut. That's all right, too. It'll work both ways. Okay, detail, that's just for your approach move. You know, whether you want to do a vector or one way or the other. And then just our clearance moves in X and Z. And then at the back of the thread also. So threading is very easy. And once you do the threading, again, you have to define a thread figure. And from there you can go general, which can be a tapered thread, metric, unified, OD tapered pipe threads, or ID tapered pipe threads. So it's very powerful. But we're just going to show you the unified. We'll select that. And again, it's just fill in the blanks, saying is it a male or a female thread, the thread diameter, the thread start point in Z, the threads per inch. We'll just put 16 in there just for an example, because I want to show you this. The length, and it'll figure the depth for you based on how many threads per inch you put there. If you press calculate, it'll come up with the radial depth of the thread. Also, another thing I want to tell you, whenever there's a number associated with an answer in a manual guide I field, the control will act as a calculator. So if we go down here and go 1 divided by 16, and then input that, it'll do the math for you. So it's capable of doing any math function that you know the symbol for, whether it's division, multiplication, adding, subtraction, tangent, cotangent. It'll do all that figuring for you. So that's important that you know that too. So at this point, we're going to cancel out of that, because at this point we've sort of went through all of our cycles within turning. So now I want to go into our tool offset data. So at this point, if we press right shift twice, 3 times, we get to a soft key where it says TOFS. If we press that, that takes us into our tool offset table. Now, as you can see, we've got 3 separate tabs. We've got geometry offset, wear offset, and tool data. And for Manual Guide I, it's critical that you fill out all of this data as much as you can based on the information from the tooling that you're actually loading your turret up with, or your tool changer, or whatever you might have on your lathe. But it's very important that you enter in all this information. All right, in our geometry offset, the first 2 fields are just your X and Z offsets. This is when you go measure your tools using this or a tool setter or whatever you might have on your lathe. So I don't have any values in there because I don't really have a real machine on my simulator. So we're not really going to go over that at this point. We'll go into that in more detail next month when we do the full lathe program. Now we'll change the cursor as we page over. The next value that we need to fill out is the radius. And what that's asking for on a turning tool is the radius of the actual insert. So that's what it's asking for there. I know on my tool, this is an 80-degree left turning insert. I'm using a 31 thousandths nose radius tool. And where I get that number from, let's do this. We're going to go get out of NC Guide for a moment, back into the PowerPoint presentation. And here it's saying tool geometry. And down at the bottom says the radius of the insert R and the geometry of the tool should only be inserted in the geometry page of the offset register. So it's important you enter those. And what it's after for in the radius input, on the number of the insert that you're putting in your tool, there'll be a number associated with that. Usually it's 4 letters and then 3 numbers. The last number is the radius of the size of the radius of the tool. A number 2 is a 32nd radius. A number 1 would be a 15,000. A number 3 would be a 47, and so on. So it's important that we know what those are so that we put the correct number in there. All right, because otherwise, if we had the wrong number there, the control is going to spit out bad information. So it's very important that we have the right number there. All right. The next one's very important also, the virtual tip. Because what that's used for is the orientation of the tool. The ones you're going to use the most, a number 3 is typically going to be an OD turning tool. A number 2 will be an ID boring bar. A number 7 will be a drill. Those are going to be the 3 that you use the most. That's what you see on this first page, tools 1 through 7. We have a 3, 3, 3, 2, a 3, and then 2, 7. So typically with that, that's what you want there. And again, we're going to jump out of this just momentarily just to show you some of the things, where we get those answers. Tool orientation. This is for a turret on the top. And see, it shows a turret here with a 3 with that orientation. That's an OD turning tool. A number 2 would be a boring bar. A number 7 would be drilling on center. A number 4, as it shows in this diagram, would be a reverse turning tool. The next one shows it a little better and just describes it a little better. Right external tool is a number 3. Number 2 is a right internal tool. And number 7, as you can see, would be a drill because it's on center. All right, this is tool orientation based on a bottom turret. Again, it still uses the same numbers. For this little diagram here, the number 3 is still a turning tool. The number 2 is still a boring bar. And number 7 is still a drill. But it's very critical that we get that information correct in this field, because otherwise the control is not going to understand what you're going to want to do, and it's going to come up with alarms that you might not understand. So it's very important that you know the correct data to put in this field, the virtual tip. All right, it's critical. All right, now as we cursor on over, now we're on the next tab, the wear offset. Again, the X and Z axis. This is just where you fine-tune your offsets. Say if you're turning something with a close tolerance and you want to offset your tool to allow for tool wear, this is where you do it. X and Z. The radius value, you don't have to put a value here in your wear offset. You only need to have it in your geometry offset. The virtual tip, this will automatically pick up whatever you put in your geometry offset. So it's only necessary to put it in once. You don't have to put it in several different times. All right, now the next tab, tool data. This information is very important for Manual Guide I, because this is where you tell it the type of tool you're using, the cut angle and the nose angle of the inserts, and then also for the simulation, the setting key. So the first thing we go into is the tool type. And it's important you have this correct, because when you do an OD turning cycle, it needs to know that you're using a general turning tool. And that's on our first menu. We've got general, we've got threading, grooving, a button tool, or a straight tool like a neutral tool, like if you were going to do profile pulley grooves or something like that. That's what it has. We go right shift. That takes us to our next set of tools. These are on-center type tools for a lathe. You have a drill, a chamfer, a flat end mill, a ball nose end mill, a tap, a reamer, a boring bar, and a face mill. Then if we go right shift one more time, we have one other tool. This tool is like a turning tool that's like a grooving tool. You can groove and turn and face with it. So that's all of our different selections. Okay, in my tool setup here, on number 1, it's a general tool. That's the type. Then setting. As you can see here, it's got 16 different selections. This is basically for your simulation. What you need to do is look at the tool that you have in your particular machine and see how it corresponds to these 1 through 16, and that's what you need to put there. That's what you need to put there. I've got a number 1 because, as I said, I know mine. It's an upper turret, 80-degree turning tool. And so that looks like a number 1 in these fields. All right. Now the next one, cut angle and nose angle. These are very critical, because if we put the wrong information here, you get all kinds of bad information when you actually make the program. As I said, the tool that I have in my machine, it's an 80-degree diamond tool. And with that type of tool, it always has 5 degrees of clearance on the front side. So if it was perfectly square, it would be 90. So you take 90 and add the 5 degrees of clearance, and that's where you get to 95. Then the nose angle is the actual shape of the insert. Shape of the insert. Not the clearance relief on the backside, but the actual shape of the insert. All right, and at this point, we're going to jump out of this just for a second again to go back to our tool data. That actually shows our tool data. And then what it wants in our cutting angle and nose angle. This screen is from the actual page in the FANUC manual of where it describes this. But what it does, it draws a line that's parallel with the holder width, and that's where it comes up with the angle. And it shows all the different settings. And then also, this information is provided by SECO, but this is just some information about some different types of tools. The ones you're going to use most often. The first one is the 80 degree. You're going to use that very often for roughing. As you can see, it's 95 degrees is the lead angle typically for that type of tool. Then the next two are 35 degrees and 55 degrees, and both of those, typically the front angle clearance is 3 degrees. So you're going to have 93 degrees as your front angle. Then the last one is a trigon, and again, it's like the 80 degree type insert, and it has 5 degrees of clearance, so it's going to be 95 degrees, and then you put 80 in the shape of the tool. Now at this point, we'll go back to NC Guide. So that's the type of information you on these first four. I've got turning tools, so 35 degree with a 93 degree cut angle, and 93 degrees with a 55. Those are all my turning tools. Basically a rough, a finish, and a semi. With those tools, you ought to be able to get into almost anything. Then the next one's just a boring bar, but again, you describe it the same way. Then to go on to some other tool, when you define it as a groove, that's the tool type. Again, you just pick out the setting of what the tool that you have in your machine looks like, and what it wants is a tip width, the tip length. And that's what it wants for a grooving tool. Then for a drill, all it asks for is the orientation based on your type of machine, and then the angle on the drill. Then also one note for when you're doing this, you need to go back on a drill. If you want it to show up in the simulation, you do have to put a radius value here, because then it will actually show that size drill. So it's important you put a value in there for a drill. In a tap, you don't have to put a lot of information, just the tool type has to be correct, and then the orientation. On a horizontal lathe, it's typically going to be a number 2 for the left spindle. Then for drilling, threading, you don't have to put a lot of information, just the right tool type. Again, the setting based on what your tool looks like, and then the angle on your insert. Very simple. But it's critical that you get this information correct beforehand. And a chamfer tool, general, and then a flat end mill, again, just the orientation. So that's all the information that we typically would put into our tool offset data. And then just to show you, this is what a typical tool offset screen, once you get all your tools set up, what it looks like. And you need to have all this answered, because otherwise you're going to have issues once you actually start doing programming within Manual Guide I. So that's the tool data. We sort of went over everything there. Now at this point, we want to go over our fixed forms. We want to talk about our fixed forms. And when you first go into Manual Guide I, this is your typical first screen in Edit. If you go right shift, and there's a soft key fixed forms. And it takes you into the fixed forms that usually this might be empty in your machine. And it's critical that you go in and set up different fixed forms. And just to let you know, Form 1 and Form 5, they will always be the ones that when you go into start or end, that's what Form 1 and number 5 are. Form 1 will be the start ones. Form 5 will be the end. And what you do, you just go in and set them up. As you can see, I've got tool change, start spindle, start lines, tooling on, whatever you want to put there. You just set it up however you want. As I said, Form 1, these are start of the program type commands. And what I do in Form 2, usually I set up cut speeds for different types of material. As you can see, I've got mild steel, I've got stainless steel, aluminum, cast iron, preheat treated, brass roughing, and then finished feed rates and cut speeds for that also. And number 3, I've got drill cycles, tapping cycles, turning cycles, threading cycles, where if I don't want to use the cycles within Manual Guide I, I can just go use these, just paste them in. Form 4, I've got calling up subroutine, or do a G10 assigned value type of thing, or just starting a spindle. Form 5 is just end the program. I've got a parts counter macro. I can just paste that into any program. And then when you actually want to put that within a program, you just press insert, and it actually adds it to a program. Now, I showed you my fixed forms, and after this is over, if you need to contact me direct. I can help you with develop these fixed forms. But then to actually make them yourself, if you go right shift until you see a soft key called settings, you go into that. It takes you into the basics where you can either set them up for milling or turning. We'll select turning, select that. Then it takes you into this where you can actually go in and make your own fixed forms. And again, it's got form 1, 2, 3, 4, 5. You can have up to 10 in each one based on the size. If you want ones that are bigger, you can cut it down to 5 if you want. And you can see down here, you can go new, alter, or delete. What we're going to do here, just to show you how you make a new one, we're going to go down to number 10 and delete that one. I'll say delete. And see, it says, are you sure you want to delete it? So it's never going to be one of these things where you accidentally delete something, because you got to press the button twice in order to delete it. So what we're going to do, we're going to make a new one. If you press new, it comes up with this. And the first thing it wants is the name of whatever fixed form that you're selecting. And we're going to say clockwise with coolant. Press enter for input. And then it says registered sentence. And I know that's M13, end of block, insert. See, it puts it into that. Wherever the cursor is, that's where it is. So we made a new one there. So that's how you go through and add fixed forms to your actual Manual Guide I. You just go through all the tabs and put whatever you want in there. Like I said, these are ones I developed for myself. I understand what I want. But again, this gets into that flexibility that we talked to before. You set these up however you want. Because, like I said, different people want to do things differently. So it's very important that you set these up the way you want them. And then to get out of that, just go to Menu, Cancel, and we're right back into NC Guide. And then one quick thing I want to go over right while I'm in this program. As you can see, I got a cursor over each particular spot in the program. And see, when I put it over the M5, down here at the bottom it says M5, spindle stop. I cursor down to G30, it comes up and says, okay, G30 is a second, third, or fourth reference position return. M30, it knows it's the end of program. G1900, that's cylinder blank figure. That's part of the learning tool that we talked about earlier also. As you page down through the program, it'll tell you what everything is. G90, G40 gives an explanation of that. So at this point, I've sort of covered everything I want to cover today. We went over our tool data. We went over fixed forms, how to create fixed forms. So at this point, as I said at the beginning, we are going to have 3 different Part 1, Part 2, Part 3. So at this point, I'm going to turn it back over to Mark for any questions we might have. And then thank you for attending today. I've enjoyed talking to you, and I'll help you out however I can. Thank you.
Hey, thanks, Jody. That was a very interesting presentation, and I'm looking forward to the follow-up programs as well. So let's look at some of these questions here. One I'm going to start with one because it's pretty basic, and I'm sure we want to get this settled right away. And the question is this a standalone unit, or can I add it to any FANUC controller?
Oh, no. It's you can add it to existing as long as you have hardware that would support, the memory that it takes for manual guide eye. You could add it to controls that don't have it.
Okay. Early in the program, one of our attendees was interested in showing a roughing cycle for a hollow cylinder. So I don't know if maybe you can just touch on that briefly now that we're this far along, but there may be some comments that you'd like to add on that particular process, that operation.
They wanted to do a roughing process for a hollow cylinder?
Roughing cycle for a hollow cylinder.
Oh, yeah, that's no problem. I mean, it's just when you're doing a turning cycle with a hollow cylinder, say you're boring out the inside of it. And the last move that you would make would actually go down to the smallest size of that hollow cylinder, and then the control would know that that was where the stock would be removed. So it's very simple to do that. It's just based on the geometry that you described for that hollow cylinder within the turning cycle. That's how you do that.
Okay, thanks, Jody. Here's a question. I hope you know what they're asking. What's the difference between CAPS and manual guide eye?
Oh, okay. CAP? Okay. CAP, that's what's usually on the make controls or some of the, it's not an ornate version of manual guide eye. It still uses the same cycles, but it doesn't have the same graphical front end as what manual guide eye is. It's still got basically the same function. It's just not as pretty.
Okay.
Not as pretty. Hopefully that answers that question.
Yeah.
But it still works. It works exactly the same way. It doesn't have the same graphics interface up front.
Okay, good. All right, Jody, how about this one? Can the G-code output use G70, G71, G72?
No, I'm sorry. Say that again, Mark. I didn't.
Okay. Can the G-code output use G70, G71, G72?
Yes. Yes, it can. Yes, it can. It will use
Okay.
those cycles. Yes, it will use
Okay.
that.
Can you tell us what those cycles are, just for those who may not be aware of what those stand for?
Oh, yeah. G70, that's a finished turn cam cycle. And a G71 is a rough multi-pass rough turning cycle. And then G72 is typically either used like in grooving, rough grooving cycles or rough facing cycles. But it will use all those.
Okay, good. This question, so I should have similar cycle on FANUC 31i model? Does that make sense
Yes.
to you, Jody?
Yes.
Okay.
Yes. 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 You can have manual guide eye on a 31i. That's correct. Yes.
Okay. Let's see here. Where do I get the software for the PC? NC Guide, in parentheses. Does that question make sense to you, Jody? I'm not exactly sure what they're looking for.
Yes, that's the offline version of the software that supports manual guide eye. And you should be able to get that either from your dealer or call us direct, and it's someplace like that. Wherever they bought the machine should be able to get them in touch with the right person to procure a manual or MC Guide.
Okay. Let's see what else we have here. We have manual guide eye on a new machine. Is it set up similar to what you showed us today, or will we need to set up a lot of the menus?
No, it should look exactly like what I showed today. It should be set up exactly like that. It's just a matter of getting to where you navigate through all the different screens, to be in the right mode, to be in the right screen. And that's just a matter, I think, as we go through our different webinars of, teaching how to use it, that they'll be able to find the same pages that I went through today.
Okay. Do any of your training tools have any sample programs?
Yes, they do.
Okay.
There'll be samples within those, both a G-code type, or if they want to see a whole manual guide eye program that was made totally in conversational, I'll have something like that too, a sample, if that's what they need.
Okay. Let's see. Jody, this question, how do I change the shape of the blank?
Okay, that's an easy one, and we sort of went over that just a little bit. But if they look at the screen here, if you go to the Start button, and then there's the blank key, if you just go, or if you were in a program, either way. Like the program that I have called up here, if you arrow down to where it says cylinder blank figure or whatever figure you have, you press the Alter button, soft key there. See, it takes you back to within that cycle. Then you just, like I have 4 1/4 for the diameter. If I put 5.0, input that, and say Alter, and see it change it in the program. It's very simple. Because the mistake a lot of people do, because what it does, Mark, it always defaults to the last blank figure that it had. And a lot of people don't actually put this in their program, so it's important. Number one, you put it in the program, and that's how you actually go in and change it.
Okay. Let's see. How about this question? Is there any possible way to get more information for engraving in Easy Guide? And I think that is looks like a custom version on Doosan's machines. I don't know if that's going to help you with that, to answer that question or not.
Yeah, Easy Guide is the way that, because, some of our builders do, make it special for them. And the engraving on Manual Guide Eye is very simple. It's just fill in the blanks. But to be honest, I'm not totally familiar with the way, if there's something different on Easy Guide than what I'm used to on Manual Guide. I'm not sure what the differences are, to be honest. I'll have to do research on that. But the engraving in standard Manual Guide Eye is very simple. Very simple. You just go in and tell it, what you want it to say, the size of the letters, and which direction you want it to go, 0, 90, 180, or 270 degrees.
Okay. Jody, some more questions are popping in here. I'm trying to keep up with them. Let's see. Is there any way to create balanced turning using G68, using Manual Guide?
Balanced turning using what G code? G68?
G68. Does that help you?
Yeah. I'm not sure. I'm not sure, to be honest. I've never tried using that. I guess it could be possible, but I'm not sure.
Okay.
I'll be perfectly honest.
Yeah, well, Jody, with as detailed a presentation as yours was, we're going to get some complex questions here, so I'm going to go through these and see if we can answer them as best we can. This question is, how about complex contours? How would you define this?
Well, that's where when you go in to do a turning figure, Mark, you get into, you can go in and you draw it. And once you select that, it takes you into a screen where you define the start point. I'm sort of showing it here. And then you have lines, arcs, clockwise, arcs counterclockwise, corner radiuses. And like with a line, you select line, you got all these different selections, whether the line's going right, right up, left up. So you can draw complex figures. As long as you got a good print, you're more than capable of drawing it on Manual Guide Eye. And, you know,
Okay.
it'll do tangent connections. So it'll pretty much do whatever you want. It's just based on, like I said, number one, having a good print and somebody that understands a good print.
All right. Jody, the question maybe then is just a general question. Can I import geometry data into the software? Maybe you could tell us how that's done.
No, you cannot. You cannot import like a DXF file or an IGES file. You actually have to type in the data yourself. At this point, we don't have the capability where we can import the geometry from outside.
Okay. Okay. Now here's a question from a listener. Is it capable of part probing?
Yes. Yes.
Okay.
It is capable of that. You can do probing where it will go in and measure a bore or find a feature. Yes, there are probing type cycles within Manual Guide Eye. Obviously, this is something where you have to go in and set it up correctly. There's a little more setup associated with probing type stuff than what there is with the basic turning and milling stuff.
Okay. Here's a good question. How do I change Manual Guide Eye to inch? Most of my inputs seem like they are in metric.
Well, on any standard control, you got the capability of changing it from inch to metric. So it's basically, the same way that you do it on a standard control. You can use a G code to do it, or there's in your settings, you can go in and change it there.
Okay.
But now, just a further answer to that question, there's some things that you have to set up where you have to be in metric mode. Like in probing, when you go in and actually set up the probe, it'll tell you in there that everything has to be done in metric. Okay.
Okay. Jody, I want to keep going on these questions. I know we're getting some good questions here. Just a reminder to everyone, if we can't get to all the questions while we're on air, we'll get to those questions after the webinar is concluded. So nobody will get left out. The webinar is being recorded. It's going to be available online. So if you can't stay for the whole session, you can catch up later. So let me get to this question. Will NC Guide work on 64-bit Windows?
NC Guide. Yes, it should, I believe.
I mean, yeah, Guide. Yeah.
NC Guide, yes.
Okay. Let's see. A couple questions about simulating a program. One question was, can we see it says, can you show a toolpath simulation example? Is that possible for us?
Oh, sure, I can do that. Here, let me go. Let me get rid of that. Well, I sort of added something to this program that I had as a sample. If we go into Auto, then Simulate, SimLab, then just press, and I just do it a block at a time where it will be able to see it a little better. And see when it did it very quickly, obviously, but because it does it faster when you're on a computer than what would actually do it on a machine. But as you can see, it comes up and it goes through. What it does when it's doing a conversational program, Mark, it'll go through and read all the geometry before it actually goes into it. So see, now there's a tool. It does a rough cut, another rough cut. I'm seeing it showing the tool, and I'm showing it like it would be on a VTL type machine. That's how I got it configured right now. Mm-hmm. See, it's going all the way through and cutting the entire part. I'm just going block by block at this point. Then if I press start, then it'll do it much faster. And there's a simulation.
Okay, thanks, Judy. That really does add to some of the things that we've been talking about and looking at. This question, and I might just, if I can get to all the other questions, let's do this one. How often is factory training available for manual guide eye?
Typically, now, depending on where you want to do it, obviously, because we only have so many trainers that we send out to do training in the field. Usually at least once a quarter we'll have manual guide eye training, I believe, in Hoffman Estates. And in some of the outlying offices we'll have training classes intermittently also. And then you also have the capability of paying to have on-site training for manual guide eye. So at least once a quarter, and then based on if you'd want to have it at your own facility, we can do it there and try to set up a time also. But that's, that's all up to the training department.
Okay. Jody, I guess seeing that simulation sparked a couple more questions. One viewer wants to know, says, I see the simulation is running faster. Can we get the actual cycle times?
Yes. When you have it on an actual machine, now, because I don't have it set up on mine, but when you do, when you go into the O list, if you go right shift for each, see how it has time here, cut time? When you have it set up totally in your machine, it'll actually give you a cut time and then non-cut time, like for doing tool changes and everything like that. Yes, it will do like a time study for you. And I'm sure that's what they're wondering.
Yeah. Okay, that's a good answer then, Jody.
Yes.
Here's another question. How can I define a tool shape / form outside of manual guide eye for simulation with my CAM programs? Is that possible?
Yeah, because there's a certain data. You can spit out all the data from the tool offset within manual guide eye.
Mm-hmm.
And I believe with that, we can actually put it, because I think this is probably somebody like with MasterCam or something like that, where they'd actually want to input their tool data into this.
All right.
It is capable of doing that. Yes.
Okay.
But there's nothing that I can show you a sample of with what I have today.
All right. Question here. When you touch off the tools, normally do you have to input them again, or will the iGuide pull them into the setup?
Oh, yes, yes. Because this is the same data that's on the CNC side. It shares that information. When you measure a tool, it will pick up the data from your standard tool offset screen.
Okay. Let's see. Can I run manual guide eye programs from the other program screen on the control? And I think, Jody, we're going to probably make this the last question here. So can you give us an answer to that one? Can I run manual guide eye program? Okay.
Yes. You could go to the G-code side and press cycle start in auto, and it would run the G-code program. It would run the conversational program. Yes.
Okay, good. All right, Jody, again, thank you for presenting your slides and showing us the workings of the programming system. This is really neat and it's a lot of detail here. For those attending this afternoon's session, you can contact FA America if you'd like more information, and we're going to get that contact information up on the screen here. And so we really appreciate the time everyone's taken with us this afternoon, and we hope you found it worthwhile. Stay tuned for the next installments in this series here. So thank you very much for taking part. My thanks to all those who arranged this session and helped it go very smoothly. This concludes our webinar, so have a great day, everybody. This is Mark Albert at Modern Machine Shop Magazine, signing off.